Okay, hello everyone. Thank you for joining. My name is Patrick Moran. I'm the Community Manager for Apex Users Group. Your presenters today will be Ashwin, Product Manager at DataTorrent and Committer for Apache Apex, Sanjay, Engineer at DataTorrent, and Venkatesh, Engineer at DataTorrent. This webinar is being recorded and will be made available on YouTube after the session has ended. Presentation slides will also be posted on SlideShare. Feel free to ask questions throughout the webinar. We will answer them as they come in. And we'll also have some time at the end for a Q&A session. Starting us off today will be Ashwin.
Hi everyone, this is Ashwin. So today we are going to talk about big data, AppHub, and application templates, and we are going to do a demo of a couple of application templates we have. One is Kinesis to S3 template, other one is S3 to HDFS. So before jumping into the application templates themselves, I want to start off with why application templates and how it fits into what DataTorrent does. So DataTorrent was started with a vision to productize big data, right? By productization, what we mean is it's both being able to build your applications, launch them on time, but also keep your cost of ongoing operations low. So the real focus is on total cost of ownership here. It's time to value plus cost of operations. And to do that, we focus really heavily on simple interfaces, pre-built applications, pre-built operators, heavy focus on code reuse, etc. Depending on looking at the patterns that we see in various use cases and so on. Right. Before talking about app templates, for any big data applications to be built, you need an underlying framework, right? That supports a certain set of features. And the underlying framework, the distributed processing framework for us is Apache Apex. And Apache Apex actually supports these underlying features that are required. So one thing is it needs to have a bunch of connectors, both at the source level and the sinks level. So to be able to read your various types of data, right? And then once the processing is done, you need to be able to ingest into various types of downstream systems as well. It needs to support unbounded and continuous data streams. So for streaming use cases, also batch use cases, right? And Apex supports both. And it needs to do in-memory processing to allow for fast throughput, right? High throughput and low latency end-to-end, right? And that's supported as well. And the other thing that really works out of the box on Apex is stateful operations. So you'll be able to do things like aggregations, rules, and analytics, and so on. And the diagram below represents a typical pipeline for an Apex application, right? And so, for example, here one of the use cases typically is that you are serving your website or your portal on the web server, and you're continuously generating those web server logs. But then you want to analyze the logs for various metrics such as maybe number of pings per country or number of pings per city, number of pings per network, and so on, right? And you want to be able to aggregate in real time and look at trends on them. So basically, in this example, what it shows is that as your logs are being generated, you ingest them into Kafka so that they are available in real time as a message bus, right? But then Apex uses multiple operators in there to be able to read from Kafka and then do some processing such as decompressing, parsing, filtering, and then finally there is a dimensions aggregate that keeps aggregating your data on various dimension metrics and then publishing them back to Kafka, or you can directly look at the real-time metrics on the UI. So this is an example pipeline how it looks like on Apex, and the features underlying within the platform support being able to scale this and do it in a fault-tolerant fashion, right? So in all, an end-to-end pipeline actually looks something like this in general at a very broad level, right? So you have your data sources like the web server logs example we just saw, or sensor data, or clickstream data, right? Or app server data, and so on. All of this data typically gets into either your message bus or sits on files within your file systems, or even traditionally they are in databases for transactional data, and then you create extract files or directly access the database, right? So for a processing engine like Apex and DataTorrent, these become the sources of the data. So these are the message delivery layers that make data available for DataTorrent and Apex. So Apex actually has connectors for a bunch of message buses out there, and the file systems and databases on the input side. Similarly, it has the connectors on the output side as well. Some of the examples are here, such as Cassandra or Oracle, Hive, Amazon S3, HDFS, HBase, and so on. It can also do MPPs such as Vertica and so on, right? And so Apex in this whole diagram, where it fits in exactly is the processing layer, right? So if you want to do distributed massive processing of data while keeping your latency really low, then Apex is a good fit there. And Apex is Hadoop native, so it lives on YARN and HDFS, right? And if you have Hadoop installed, then you don't need anything else to be installed there. So you just either run Apex directly, or you install DataTorrent for the management console capabilities, and then you're ready to go. Right. So in terms of the stack for DataTorrent itself, it looks something like this. So basically, all the way at the bottom, you see the infrastructure layer. So Apex can run on cloud or on premise, right? And then it needs Hadoop. So you see the layer on top, which is Hadoop 2.0 plus, which is YARN and HDFS. Now, once you have YARN and HDFS, now Apex can run on top. So Apex itself is has the open source two layers in there. The bottom layer is a Apache Apex core, which is the stream processing engine. It is typically responsible to get your resources from Hadoop and then launch your processes in those containers, right? And then make sure that the heartbeats are going normal and typical the bookkeeping and health of the system is taken care of the Apex core, right? And if something goes down, it gets new containers, relaunches the process, and make sure that it continues from where it left off in terms of the processing, without any manual intervention, right? So that is a platform capability as a framework. But when you build your applications, you need to be able to do a bunch of processing logic. So typically, there is a combination of general purpose processing logic and then your business logic, right? So the general purpose processing logic, such as reading from Kafka or reading from a file system, and then doing parsing and then filter, transform, and so on, all of those have become individual operators on an Apex application. So what we did is we built out an operator library which has a bunch of those operators, and you can connect those operators together to build your pipeline. And if you need any business logic to be added, you can create your own operator and make it part of your pipeline. So these operators are also available as part of the open source Apache Apex, and you can use those operators to build your pipeline. Other things we have on top are high-level API to be able to create your, it supports a couple of things. One thing is be able to bind to higher level languages such as Python, right? Or you'll be able to do dot notation applications, something like, my input dot parse dot map dot filter and so on. So that's supported by high-level API. On top of the open source system itself, there is DataTorrent components. There are two types of DataTorrent proprietary components. So one is all the way to the right. You see the ease of use ones, which are your which is a tooling essentially. So the tooling is really focused on developers, operations persons, and also providing business visualizations, right? So basically, for the developers, it enables rapid development and so on, and you can also build your applications for basic stateless kind of apps by drag and drop visualizations. Other things you can do is there is management and monitoring console, where you'll be able to track how your application is doing in terms of throughput, in terms of latency, and you'll have access to logs from there. It keeps continuous track of various events that are happening. So it makes life easy for developers who are debugging their application, but also for the operations persons who will need to make sure that the application is running up and running all the time. So for ops guys, there are things like alerting on various metrics, and there is various events that show up there, and it also shows resource utilizations and so on. Right, and other things we have are application templates, and that is a focus area today. We're going to talk about application templates are essentially repeatable patterns in terms of applications we see. Let's say, for example, if someone is reading from Kafka and writing to HDFS, that's a common pattern. So we created application templates. And other thing we have is the industry solutions on top. Basically, industry solutions are taking these application templates and then applying them to a particular use case in an industry. So, for example, financial services fraud prevention. has basically, to be able to prevent your fraud in real time, you should be able to ingest your data in real time. You should be able to enrich your data in real time, right? And then apply your fraud rules in real time. So all of that becomes different app templates that are combined together to become your fraud prevention solution. So as I said, so why app templates? Essentially, it is repeatable application patterns, right? And then be able to do code reuse at the application level. Right. So what we have seen while working with customers and users is that there are multiple types of patterns that are emerging in terms of use cases. So there are simple data integration type of patterns where people want to simply move the data from point A to point B. For example, move data from S3 to HDFS on a nightly basis, right? And you want to have a scalable process to be able to do that without manual intervention. That's one use case. Other use case is be able to do raw data ingestion from a streaming source, let's say from Kafka, into your data lake like HDFS, right? And other use cases are like disaster recovery, cluster backup, and so on. So that's one type of use case we have seen, whereas which is simple data movement, but no processing in between. Other type of use cases we have seen is data ingestion or data integration type of use cases where people want to move data from source into a data lake or a store like Cassandra, but they want to do some processing in between before doing that, right? For example, you might want to read data from Kafka and then do deduplication of your data on a certain key, and then enrich your data and do some transformations and filters, and then write it to HDFS or Cassandra. So you're achieving two things there. One thing is you are ingesting data in real time, but also in use cases where 360 views are required, you're enriching from multiple sources. Now, all of this in real time, right? So that's another pattern we have seen. And other patterns we have seen are more in terms of rule application and machine scoring for anomaly detection, fraud scoring, and so on. So these use cases have a typically message bus input followed by scoring on H2O or some kind of a machine scoring algorithm or CEP engine, and then the output you're either writing to HDFS or writing back to Kafka for your upstream application to take care of the decision that is made using these rules. Right. So while we are creating these app templates, we also needed a delivery mechanism to be able to give out these app templates to the users. So we created a template repository called as AppHub. Now that acts as a central repository where we continuously upload the app templates that we're building, and also provide version upgrades to it. And from a user perspective, you just go to AppHub and then it's available. The new app templates or the existing app templates are available right there for you to be able to easily import and then launch them, right? And we also provide a GitHub URL there, so you can directly go there and add custom logic to the applications. So if you have RTS installed, DataTorrent RTS installed, you can directly go to AppHub in the navigation bar, and there you will find the application templates, right? To make all of this possible, there are some key infrastructural components that are needed on DataTorrent, and we provide them to make it easy for the user. So essentially, our goal is to, as I said initially, it's the total cost of ownership, and app templates really focus on your time to develop and time to launch. So it reduces your TTV, time to value gap drastically. So the various components involved are, as I just described, the AppHub, which becomes a delivery mechanism. We are also doing cloud integrations. So we are providing cloud app templates. So one of the examples that we are going to see today is Kinesis to S3. We are doing two things there. One thing is provide the app templates within the ecosystems, but also make it very easy to install into a cloud infrastructure. So for example, we are providing the Amazon EMR install scripts, where for any given app template, you can directly download it from the website and run the installer. So the installer will actually on your AWS account, it will actually deploy EMR, install DataTorrent, and make the app template available for you to launch. So all within a matter of few minutes, right? And other thing we are working on is the schema support. Basically, it will enable us to reuse app templates for multiple use cases. So for example, one of the app templates we have is read from Kafka, read JSON data from Kafka, do some filtering and transformations and stateless transformations like splitting the name values or date transformations and so on, right? And then ingesting it to HDFS. Now that particular app template with schema support, what it does is the template itself is independent of the schema, and as a user you can apply various schemas on it and then use the same template for different use cases. So for example, if you are ingesting healthcare provider data, if it is coming in JSON, you can use this app template, apply your JSON, your schema on it with various fields, and then apply your filters and transformations on the same template without changing the code or the template itself, right? And the same template now you can take it and apply it on a let's say a financial services use case, and if you are ingesting, let's say, transactions that are coming in JSON format. Right, and all of this code is open source code today. So if you go to datatorrent.com, github.com/datatorrent/app templates, there you will find the source code for all of these templates. So you can clone it and add your custom logic to it if you have to add more operators. And let's say for example, in the same Kafka to HDFS example, before ingesting to HDFS, you might want to add some KPIs to it and then publish those KPIs to a database, right? So that custom logic, if you need to add, you can quickly, easily clone the source code and then add the custom logic as well. And other big thing is the app metrics and visualizations. So we also provide dashboards for key application metrics and operational metrics. So things like, let's say Kafka to HDFS, you might want to know how much data you're writing to HDFS per second, for example, right? Or how many files you're writing to HDFS per second and things like that. So those metrics operationally are helpful, but also if you want to expose other metrics such as number of errors or let's say number of fraud events, those will be application level metrics. Those can be exposed onto the dashboard very easily as well. Right, so in all, the benefits for app templates for you as a user is basically ease of use. You can easily, quickly import and launch the app templates within a matter of minutes, right? And you can easily add business logic by adding your custom operations. Other benefit is time to market and total cost of ownership. So it reduces your time to production drastically because these app templates have already been built out and available through AppHub, but also they are tested and certified by DataTorrent, right, for scalability and fault tolerance, right? And as a result, it also helps with your cost of operations. Since app templates, they are on Apex and they run on the DataTorrent RTS, all the features that DataTorrent RTS brings in terms of operability and management and monitoring, those will be applicable to app templates as well. And other advantages are real-time visualizations. So you'll be able to diagnose your applications on your metrics in real time to look at the trends in terms of your data, application data, or your operational data. Right, so we will do a couple of demos now. So the first demo will be Kinesis to S3 app template, and Sanjay will do the demo. Before that, while we are transitioning to Sanjay, if you have any questions, do feel free to ask the questions, and we will answer them. All right, so there are a few questions already, so let me take them up. So the first question is, can you do stream processing in both SAP HANA and Apex at the same time? And if so, why? So this, I think I'll need some more context on it. But when you're saying if you can do stream processing in both HANA and Apex at the same time, maybe you're asking about the differences. So Apex is basically an open source distributed stream processing framework, and typically in terms of the speed of execution and resource utilization and scalability, Apex compares and is better than actually most stream processing engines out there. So today you see there are engines such as Storm and Spark Streaming and Flink, which typically come up in terms of stream processing. There is another webinar where you can look at the differences in terms of how Apex compares to Spark Streaming and Storm, and you will see various comparison metrics to see where Apex is useful and how you can use Apex for various use cases. All right. There's another question. Can you please post the slide deck? Yeah, the slide deck will be posted on SlideShare once the webinar is complete. So there is another question which says, how do you manage MDM work with your app templates? Master data management basically, or metadata management as well, right? So there are multiple definitions for it in the industry traditionally, and they are typically managed in databases. And I think what we are seeing these days, as with the evolution of big data, is that basically the MDM service itself is depending on the kind of processing you have, it becomes a service for your big data applications. So basically, either you apply your traditional MDM as a query response and then do your metadata updates on your streaming data as it is flowing through, or you have your other processing engines to be able to manage MDM. And so one of the examples we have seen is if you want to do anomaly, you want to do matching on your data that is coming in without using a composite key. That's a big data problem by itself, right? So so it is provided as a microservice usually, and then you do a query on the service, and then you get the response back, and then that's how you use your master data in your processing, in your real-time processing, basically, as your data is flowing through. Okay, so I don't think there are any more questions. So I will hand it over to Sanjay to do the Kinesis to S3 app template.
Hello everyone, this is Sanjay. So I'm going to demo one of the app templates Ashwin talked about, Kinesis streams to S3. First, I'm going to show AppHub, how I'm going to import that template from our AppHub. I'm going to run it as it is. And in the second part of my demo, I'm going to download the source code, and I'm going to modify the source code to add a processing step, and it'll do the same thing. It'll copy data from Kinesis stream into S3 storage. So as Ashwin mentioned, we support some of these cloud offerings, especially Amazon Kinesis streams and Amazon S3. Kinesis streams is like Kafka. We have an input operator that connects to it and continuously reads data from the stream, and it can be fed to a downstream operator where you can do some processing, and an output operator such as the S3 output operator in my case is going to write it out to S3. So you can see the DataTorrent console here. I go to the develop tab, go to application packages. Currently, I have only these 3 packages. The way to get more packages, I mean, at least in this case, is go to AppHub that Ashwin talked about. We already have a template called Kinesis to S3, which is here. We can go to the page. It has some description. It talks about what the template does, some of the advantages, and once the application is running, you'll see what the logical plan looks like. The application has 3 operators: Kinesis input, and S3. On the S3 side, there are S3 output module compaction and S3 output module reconciler. I'll talk about the compaction phase later, but this is what the DAG is going to look like. So let's go back and let's import the template in my DataTorrent console. Once it is imported, I go back to my console and I can see the package. Let me go back to the application packages, look at the package view, and I can see this particular app package which I imported 12 seconds ago. I'm ready to launch it. So before launching it, let me go back to my AWS console. I'll show you that in my Kinesis, streams, I have a stream called transactions. It has 10 shards, and it has a lot of data that we have loaded into the stream that I'm going to read from my app template. So going back, by the way, the other thing I would like to show you is the S3 storage, where I have created this bucket, DataTorrent webinar K2 S3, where my output into S3 will get stored under this bucket. Having said that, let me go back to my DataTorrent console, and I'm going to launch this app. You'll see how easy it is to import the app and launch it. So let's do that. Once I invoke the launch dialog box, I get this name of this application. I just choose the default that the console has given me, Kinesis to S3. Then I need to specify the launch properties, because the app needs to know both on the input side and output side the Amazon services to connect to. So let me click on this, add required properties. You'll see a bunch of properties that I need to supply the values for. Now, for the stuff that I've shown you here in the AWS console, I have the properties or the values of the properties already stored in this page. So I'm just going to copy these. Like I said, the bucket name I'm going to use is this one. I'm going to supply this as a value of the bucket name. The output directory path, let me just use something for this session. So I'm going to call it output 21. Then these are the typically for all the Amazon services, I have to provide access keys and secret keys. It's like username, password. So for both the Kinesis stream and the S3, I think I have the same keys. Then the endpoint I have to provide for my Kinesis input. Again, the secret keys, just like the password for accessing Amazon services. The same for both. Now the stream name that the stream I showed you is called transactions. Let me provide that here. Now one more thing, couple of things I have to do is I have to add a couple of properties. One is I have to, the stream has been populated and I have run the app a couple of times before, but I want to read it from the beginning, from the earliest offset. So I need to tell my operator to start reading from the earliest offset available. The other thing I need to do for this demo is I have to set the block size on my S3 operator to 1 megabyte so that we can actually see storage getting created on the S3 side. Otherwise, what happens is until it reaches a block size, you don't see storage getting created. And sometimes in a demo like this, you actually keep waiting and you don't see anything happening. So to avoid that, I'm going to provide a block size of 1 megabyte. So having supplied all these values, let me launch this app. So let's launch it. What the launcher is doing is it's taking the app package that we imported and repackaging it to be given to Hadoop, to Yarn, so that it can start executing this application. So Yarn has accepted this application. It is processing it. My containers are coming up. Within the containers, my operators will start. And you can now see the app is running. And the app has 3 operators, basically only 2 operators. I'll show the source code and I'll see how I'll show you how the app is wired. But on the input side, I have a Kinesis input operator which gives its tuples to the S3 output module. I'll briefly come to that one, but you can see tuples getting processed here, and it'll reach, I think, 1 million or so tuples. That is what I have in my Kinesis input. So okay, coming back to the output side, so on the S3 side, we have what is called a module. A module is a bunch of operators that work together to implement certain functionality. So in this case, it is actually taking the tuples that are coming to its input side and compacting them and storing the compacted output in a local HDFS store. We'll see where that is. So let me go back to my HDFS, and as you can see, so this is my app ID. Let me just confirm my app is 610. Okay, so going back to this one, you can see this directory called compaction output dir. So the output operator is temporarily storing its data in this directory, from where the second step will take it and load it into S3. So this is going back to my DAG. It is still processing. And what I can do is I'll show you a couple of things. One is I can go back to this output operator, and on the output operator in the properties panel, you can see some of the values I supplied. So the output directory name is output 21. I mean user app user output 21, and that is where it is going to put all the data. The other thing I want to show you is going back to my application DAG. Now this is a logical DAG which just shows logically there is an input operator, and downstream we have this S3 output module. But physically, this DAG gets expanded. It has, earlier I told you that my Kinesis stream has 10 shards. So what my Kinesis input operator does, it actually queries the stream and queries the metadata, and based on the shards it has, it creates the same number of partitions on the Apex side. So you can see it has 10 partitions. And each partition connects to its corresponding shard, and that way we achieve parallelism in reading data out of Kinesis streams. So right now, we don't have parallel partitioning. You can read up about parallel partitioning in the Apex docs, but what happens is there is a unifier which receives all the data from all the partitions on the input side and unifies them and supplies them to the output module, the S3 output module. So looks like my application has finished processing everything. Let me go back to my S3 console, and I'll just go back to my bucket. You can see output 21. My data has appeared here. So let's pick, because of the block size, it has created 1 megabyte each. So let me pick one of them and download it. It has downloaded to my downloads folder. This is my file. I'm just going to go back here and show the file is 22610. You can see these are my tuples which got stored in my S3 output storage. Each tuple is basically, it's a number, string number. It's some schema. Don't worry about it now, but this is what I have. Now it is, remember what the schema is. The first field, first column is a number, second one is a string. In this case, it just happens to be some kind of a hexadecimal number, but that's just the producer program we have that generates this dummy data for this app. And the third one is again an integer. So this is my default app template in action. Now what I'm going to do is I'm going to demonstrate how one can modify the source code to achieve some customized behavior. So the customized behavior we are going to achieve is, you see this middle column, it has, it's an alphanumeric, or basically it's a generic string. We are going to uppercase this column, and that is what I'm going to achieve by making changes to the source code. So going back to my console and going back to AppHub, going back to Kinesis to S3 app, at the bottom of this page, it shows you the GitHub URL for app template. So you can click on that and you can see that the source code for this template that you just saw in action is available on GitHub under DataTorrent app templates, and for this particular template under Kinesis to S3. Now I'm just going to clone this whole repository. So let me just create some kind of a workspace. And I'm going to clone this whole repository. And over there, I'm going to go to Kinesis to S3. Now, if I just build it as it is, I'm going to get the same behavior that we saw before. So I want to modify the source code. The source code already is annotated with the changes that we would like to make. So we'll go through that code and we'll see what changes are going to be made and how that is going to achieve the transformation that we want to do. So I have Eclipse here. I'm going to import my project. Kinesis to S3. I'm going to show you the source code where the DAG was created. So the template that we saw, the default template that was imported, was a very simple DAG. It had the Kinesis byter input operator, which was named as Kinesis input, directly feeding its output into the S3 bytes output module. the stream creation, this stream connects my input to my output. So the output port of my input module gets connected to my output module's input port. So a very simple DAG that we saw before, and as I mentioned before, a module is a one where there are multiple operators kind of combined together to achieve certain functionality. And as we saw in the DAG, it has a compaction step where it temporarily creates compacted data or compressed data in a local HDFS before uploading or before storing it into the Amazon S3 storage. Now, the source code already has the comments to achieve the customization that I'm going to describe. So it says what we're going to do is, as you saw before, the input tuple has 3 fields: a number, string, number. We are going to uppercase the string, the middle column. So obviously, instead of this simplistic DAP, we are going to create a slightly more complex DAG. And for that, I'm going to create these additional operators. Let me place them appropriately here. Now let me explain this a bit. The additional operators I'm creating is a CSV parser. What it does is it takes the input tuple coming from Kinesis, parses into pipe separated tuple. It is fed to my next operator, which is a transform operator. The transform operator, you can read about it in the Apex document or the Mandala documentation. It allows us to perform various transforms. Is to uppercase the middle column, and which is what is described here by adding this rule here, where we are changing name to its uppercase version. And then we will give it to a CSV formatter operator. It formats it back into a string, and then it is then fed to the S3 output operator. But this time, instead of the byte output module, we are going to use a string one. And as the comments here say, instead of the bytes output module, we're going to use a string output module. So we have to change our operator definition to this one. Okay. Having done that, I also have to now connect up all these operators. So instead of the single stream that I've created, I have to create this bunch of streams here. So let me do that. So this is what it is. If you see the comment here, there is a simple like a diagram here: Kinesis input to CSV parser, transform operator, formatter, and back to S3 output module. So this is what we're going to do. I can build it now, but before building it, let me do one thing. I'm going to change the application name to cust because this is the customized version. I'm also going to change the output APA file. APA is our Apex application package. So I'm going to change it to something -cust, Kinesis to S3 -cust. I'm also going to change the description to include cust here. This is just to differentiate from the default template that I already have in my DataTorrent console. Looks like I'm done. Let me go to my the source code. This will show the changes I've made. I modified the POM file. I have also modified application.java file. So let me now compile it, or actually build it. I use the Maven builder to build my template. As you can see how easy it was to modify the template. The output is in the target folder. It is Kinesis to S3 cust-0.9.apa. Going back to my DataTorrent console, like is this one, I'm going to go to develop application packages, the application package view. So this is the one I imported from our AppHub. I'm going to upload the one I built just now. So I'm going to go to templates workspace for Kinesis to S3 is the one where I built my project target, and this is the one that I built just now a couple of minutes ago. This is an APA file. You can read about the APA file and Apex build process on the Apex website, and I'm going to upload it. And because of the renaming I've done, I can upload it, and you can see it side by side to the imported one that I imported from our AppHub. Takes a few seconds for the UI to validate the package. The package has been validated and it's now available for me to use. As you can see, I added the word cust, which shows up both on the package name and the application name. So there is no conflict in names. That allows me to have both my customized package and application and the original one that I downloaded or imported from AppHub. Let me launch it. Now I have not modified anything in the launch properties, so I have to supply the same properties as supplied last time. And input and output hasn't changed. The only thing that has changed in the pipeline is a processing step that we added in between. So I can supply the same properties that I have here with a small change because I'm going to use a different output bucket, or sorry, a different output folder, so that I can compare this with the previous one. So this is the output bucket name on the S3 side. My output directory for S3, I used output 21 last time. I'm going to use 22. My key access and secret keys for Amazon, we have created this specially for this session. This is my endpoint on the Amazon side. Look for Kinesis operator. Again, the secret key stuff that I need to supply so that my operator can connect to these things. I'm going to use the same stream name, transactions, so it's going to use the same data. And as before, I have to supply these additional properties to read from the earliest so that it will be add another property to change the block size to 1 megabyte. Another advantage of the 1 megabyte block size is I could download that simple file and I could show the contents. Otherwise, with the default block size of 128 megabytes, it would have been slightly more difficult. So I guess I have everything here. My output is going to go to output 22, and let me launch it. The application has been accepted by Jan. It is making the application ready for deployment, finding containers to deploy the application into. It takes a few seconds, and once the application is running, my UI will render the DAG, and you'll see the modified DAG, where you'll see the additional operators that we have added in my DAG. So as you can see, I have the Kinesis input operator, no change here, but these additional operators that I've added, the CSV parser, transform, and the formatter, I already described. I talked about these, what they do. The transform is the one that is doing the uppercasing of the middle column. And my DAG is running. It is processing these things. Going back to now the application number is 611. I'm going to go back here, going back to my HDFS, and on my this is the intermediate storage where my S3 output operator uses intermediate storage on local HDFS to do compaction. And if I'm right, we didn't look at it last time, but let's see what we see here. I guess I need to be quick.
Yes.
Yeah, by the time I get to
Yeah, it got deleted. So
yeah.
Try the 10 forms. The last one.
Okay. Okay. Anyway, never mind. We'll just go to we'll go to the S3 S3 output 22. You can see it has my output operator has already created these things. Let me download one of these. This is the one with 611 in it. Let me go to my, so it is there on my local computer. I'm going to as you can see, the middle column has been uppercased, which is what I was trying to do in my customized application. So that is what I wanted to show. And going back to this, going back to my DAG, it has processed all the tuples from my Kinesis stream, and this is all I wanted to show. Let me know if you have any questions.
Yeah, there are a couple of questions. So one question is, how does it clear the intermediate data stored in HDFS?
Yeah, that the output, the second part of the output operator, uses the API, S3 API to load it, and just because it's supposed to be intermediate temporary data, it just deletes it after the upload is or writing to S3 is done.
Right. Okay, there's another question which says Hortonworks HTTP 2.4 has encryption zones. In order to use these app templates, how would custom security encryption zone names, key tabs, principals be managed, and where and how updates can be done? Okay, I can take that up. So basically, at the launch time, there are the default properties that show up where you give the properties to launch the application, such as your access keys and so on, right? So and then other thing you can do is while launching, you can add additional properties that the operators ask for and give additional properties. Now, in case of things like key tabs and principals, what happens is the DataTorrent RTS itself. For every user, you can configure the corresponding key tabs for it. So when you log in as a particular user and you launch an application, you can use your key tab to launch an application. So in case of a secured environment where you have controllers configured, you can configure that on the DataTorrent RTS to be able to use a secure environment. Right. So another question is DataTorrent RTS an open source product? No, it is not. DataTorrent RTS is proprietary, and as I showed the stack, basically Apache Apex core and Apex Malhar, which is the operator library, they both are open source, and you can use the app templates as it is from the source code to launch it on your Apache Apex core. So if you have the Apex CLI, you'll be able to launch an application built on Apache Apex, including app templates from there. Now, what DataTorrent RTS provides as a proprietary product is a management console that you're seeing right here on the presentation. So basically, it has multiple features such as the development console, the monitoring tab, and the visualize AppHub, and so on. That really focuses on time to value, total cost of ownership, and then it has other features around LDAP and security and so on. So other thing we have is the DataTorrent RTS itself. If you want to try it out, it's available for free to download from the website, and you can get a 128 GB free license. So until 128 GB of memory consumption of your applications, you can use all the features on the DataTorrent RTS for free. And for any applications or set of applications that take more than 128 GB together, then you can contact us to get a computer license for evaluation or for production purposes. Right. Checking if there is any other questions. Okay, there is another question which says, how can you schedule the jobs in Apex on the cloud? If you are using DataTorrent RTS, there is a web service REST API that's available, using which you can launch your applications, you can kill your applications, and there are many different features on top of the API. Now, if you have any existing tools to schedule applications, such as Uzi or any other tools, you can simply call the REST API to launch your applications and schedule them, right? Or we actually do scheduling in our test clusters on a nightly basis using cron jobs, actually. So you can do that as well. And DataTorrent itself, in Apex itself, we are adding some support in terms of scheduling subtags. So here you see that there is a single graph, the tag which goes from Kinesis input all the way to S3 output, right? But then you can have this split into subtags where, let's say, the first one is writing to HDFS, another subtag is reading from HDFS and writing to S3, and maybe another subtag which is reading the S3 data and then doing some KPI calculations on it. You can actually put all of them together as subtags in a single application and schedule them one after the other. So that work is in the roadmap, and that's going on as well, if you want to use that feature. All right, I think that completes the questions. So let's move on to the next demo, which will be done by Venkatesh. And this demo is S3 to HDFS.
Okay, hello everyone. I'm Venkatesh from DataTorrent, and I'll be presenting you the second part of the demo today, which shows ingesting the data from S3 buckets onto a configured HDFS location. So let me start from the AppHub page. So to know more about this template, you can visit our page datatorrent.com and then go to the AppHub link here, which was already shown by Sanjay before while he's presenting, and you can see a bunch of app templates here. and in that you can see the S3 to HDFS sync app template, which is shown here. On clicking the more details, you will be redirected to the page S3 to HDFS sync app, which has a description video, and a logical plan, and how to configure the launch app properties for starting this app template to ingest your data. So let us look at this template, and this template is very powerful because fault tolerant, and it is DataTorrent certified, and you can use this template to launch your ingestion process in like a couple of minutes. So let's look at the description here. So as given in the description, it continuously looks up for a configured S3 directory and keeps ingesting the files as blocks from the configured S3 location to the destination HDFS path, and it maintains one-to-one traceability for the files which it is ingesting. So as discussed, the application scales linearly with the number of block readers that we have. It is fault tolerant, and it withstands any sort of node outages or any outages in the cluster without any data loss. And it is highly performant, and it is as performant as your network bandwidth is. So the only limiting factor that we can see is if you are bottlenecked on the network. Okay, and the configuration parameters that we need to provide will be the S3 connection parameters and the destination HDFS path names and file names. It will, I mean, if you want a different file name other than from the one which it is ingesting. Yes, and like we have explained throughout this webinar, so the main focus of this app template is reduce your time to market and cost of operations, because this is already DataTorrent certified. Okay, so there is this jumpstart video which is shown here. You can watch this you can go through this walkthrough video to see how to import and launch the app template again if you're interested. So there is this logical plan which explains what is being done by this particular template. We will look through these details again. After submitting the job, I will explain this in detail. So there is this set of launch properties that we need to configure while we are submitting the application, which will need us to configure the HDFS directories and S3 input directory. So I'll explain more in detail later. And the resources links are available here. You can look at the code if you want to at the GitHub URL which is shown here. So let's look at a working demo of this app template. So let me log on to my lab. Okay, so this is our lab cluster. Let me show you the the S3 files that I'm going to ingest from the directory. Okay, so there are these 3 files which are like 1.1 GB each. So we will be ingesting these files onto the configured HDFS directory now. So let's launch the job and discuss more in detail. So if you want the template, like Sanjay was explaining before, you can go to the AppHub packages, and there is this S3 to HDFS app. You can click on import, which will import the application for you. This application is already imported in my gateway, so you can see that it's already been imported. So we can go to the develop section, and you can look at the app name which says S3 to HDFS sync ingest and backup Amazon S3 data to HDFS for data download for Amazon to Hadoop. So you can click on the launch here, and so there are a couple of configuration files which are available here. One is to set the memory configuration when you are launching the job in a cluster and when you are launching the job in a sandbox. So sandbox has the sandbox memory configurations will be lower configurations, and no dynamic scaling will be configured there, whereas for the cluster memory configuration you can see dynamic scaling being available. And like we discussed before, there are a couple of properties that we need to configure, which is the output HDFS directory and the S3 input module. S3 input directory. So let us configure the HDFS directory to be /user Venkatesh S3. Let us go to the location and see what's available and what's already there here. Okay, so there is no S3 directory here. So my intention is to ingest the 3 transaction files that we have seen onto the home directory of user Venkatesh here, onto the S3 directory. And the input module, it needs an access key, a secret key, bucket name, and the directory under the bucket in this pattern. So we'll be providing those details. I already have the details. Okay, so this is the bucket and this is the directory under the bucket. So what the application will do is it will continuously poll for that directory, and if there are any files ingested onto that directory, it will start an ingestion process from that directory onto the HDFS location. So there are a couple of additional launch options that we specify, where you can specify a queue that you want the job to launch. If you don't specify a queue, it will go to the default queue, which will be the queue of the gateway user who is running the jobs, and it is me right now. So the jobs will be submitted under root.venkatesh. And there is this option to choose garbage collection and logging. So I'll choose that. It will give us more details about how the operator memory is, what the operator memory is going through. And I'll launch this job now. And since we have chosen cluster memory configuration, so the application dynamically assigns, dynamically partitions the operators that are that will get launched. So I'll explain more about them once we look at this logical DAG. Okay, so in the monitor section, okay, so there is this app which got started 24 seconds before. So let's look at what's happening. So it started this logical DAG, and it is dynamically changing the partitions, the number of instances that each operator has, depending on the load that it is going through right now. So we will come back to that once the operators are completely dynamically assigned to it and it starts reprocessing again. So from the logical plan here, okay, so before going to the logical plan, we'll look at the code. So the code is available under DataTorrent app templates. It is S3 to HDFS sync, source main apps. So as you see here, including the import statements and the license agreement, and the license dog that we have here, the complete code for this application is like 51 lines. And to go into the details, the application annotation has the application name S3 to HDFS sync, and this is the same name which we are seeing here. And so there is this populate DAG function which passes the DAG object as a parameter, and the first couple of statements are adding operators instances onto the DAG. So what these statements does is, there is this S3 input module which is available in Malahar, and it will create an instance of this module, and it will add that module onto the DAG, and there's this HDFS file copy module here, and it will create an instance and add the instance to the DAG. And once the modules are added, we need to connect them. So there is this stream that we define, which connects the output port of the input module to the input port of the output module. And there is this metadata information which we send, and that will also be passed. And the same is true for the last stream that we have added. It passes the messages from input module to output module. So now let's look at the logical DAG to see what these input modules and output modules are doing. So from the logical plan here, so you see there is a file splitter and a block reader. We need a file splitter because the files that the files that are getting ingested could be of different sizes, and since a block reader will be assigned to read a particular file, there could be skews depending on the different file sizes that we are dealing with. So to avoid this problem, we have a file splitter here which splits every file into chunks, into blocks, and each block is assigned a reader, and you can start reading the data parallelly and very fast, and it will be very fast. So we need a synchronizer because so there will be metadata that will be sent from the blocks that we are reading, which gives us the offset positions, initial offset and the final offset, along with the file block metadata information, which will be used to stitch the files together in this file merger app. Because like we have said, one of the feature of this template is maintain the traceability. It has the same file name from the S3 buckets to the HDFS location. Okay, so there are different tabs here: logical, physical DAG view, like Sanjay was explaining before. I will go through the same again. So this is the logical view where you can see different parameters here. So there is this drop down which gives you different parameters to choose. You can see the CPU utilization from this place. You can see the total processed per second, latency, and there is this stram events which explains the lifecycle events of the operators. If there is an operator failure, it will be notified, and you will be notified here. If there is a new instance of an operator getting restarted, you can see it here. So basically all the lifecycle events will be notified here under the stram events. So there are different parameters that you can monitor here. You can go through this section, and going back to the physical view, you see the physical, the instances of the operators that have launched here. So if you look at the instances, there are like multiple instances of the S3 block reader launched on different hosts here. So this is like an instance of an operator getting launched on different nodes dynamically. And these are all clickable links for the containers which you are seeing here. You can click on the container to see what's happening on the container from this UI that we have here. So it shows you the garbage collection stats of the container, and this is a wonderful UI which will help you when you are when you are worried about your memory usage. And there is this logs tab that we have here, which shows us different log files. There are GC logs which are available for you to monitor. There is this DT log, which on clicking will provide you the logs. So these logs are available on node 20 because the application is still alive. It will be on the configured log location on this server. So the logs will be tailed from that location, and and if there are any errors or some information statements that you have put, you can view all those logs from this from the UI itself, and there is this option to continuously tail the logs, uh, which does that for you instead of refreshing this page again and again. So this is about the physical view, and there's this physical DAG view which shows you what's really happening from the logical view. So so the DAG is so huge, so I have to minimize to show you everything I'm trying to show. So this is the complete physical DAG which is actually running. So there are these multiple instances of S3 input block reader and block reader which got deployed depending on the load which is coming in. Okay. So the ingestion process should be complete by now. So it has processed 60 blocks and has written 3 files. So let's go to the location and see and we find. So there is this S3 Okay, so you see the 3 files are already ingested. So let's look at what's there. So you see some transaction data which was there in the S3 buckets is being ingested onto this HDFS location. Okay. So if you are interested in looking at the code and changing some configuration parameters on your own, you can go to the DataTorrent app templates GitHub location. You can clone the repository like Sanjay was referring before, and add some add some additional operators depending on. If it is something more that you are looking at, you can add your custom operators also to the same application and import and run your job. So this is all I have.
So there are a couple of questions. One question is, what is template? Can this template process glob and blob content from source to destination? If yes, how and what changes need to do and where?
So this is basically a block reader which takes in byte information and process it. It doesn't have to deal with the type, the class of data that you are dealing with. So.
Yeah, so basically this app template is independent of the underlying data format. You don't have to worry about the character set or any of that stuff. So it's essentially moving bytes from point A to point B. So as Venkatesh explained, this template essentially takes your input source files and then moves them from A to B as blocks, right? Splits them into blocks and then reconciles them into the actual files themselves, right? So you don't really have to worry about what the format of the data is, and so it's irrespective of what the format is, the files will appear in your destination as well. Okay, another interesting question. Is there map reduce behind the scenes?
I don't want to answer this question. No, there's no map reduce behind the scenes. This is all based on Apex platform, right? Which is completely different from MapReduce, and this is completely in-memory processing that is happening here.
Yeah, yeah. So adding a little bit on that, as Venkatesh said, it is built on top of Apex, and Apex as a platform is far more superior compared to MapReduce. It's in memory and it's highly scalable, and fault tolerance is built into Apex, and it supports a lot more use cases in terms of both streaming and batch. So in specifically for this use case, because it moves data in memory, not writing a lot of intermediate files and then shuffling them together. This is way faster than MapReduce of a typical ingestion pipeline. Okay, another question is, would it be possible to interface these templates with Docker or container-based customer application? If yes, how can that be done? Yeah.
Yes. Go ahead.
Yeah, so I can answer that. So basically, if you have your cluster Dockerized or containerized and Hadoop is installed on it, right? Apex essentially depends on Hadoop, and if you have Hadoop installed in whatever fashion in VMs or in physical machines, Apex is independent of that. It is agnostic of that. So basically, if you have Hadoop installed in your containerized cluster, then Apex can run on top of that. So there is explicitly there is no changes that are needed for Apex or DataTorrent. So it will run in your environment if Hadoop is supported. All right. So do feel free to ask any more questions you have. And in terms of the demo, just hold on a second. I'll just transfer this to my GoToMeeting panel. So. All right, yeah. So basically, I think in terms of the questions, they are answered, right? If you have any more questions, do feel free to ask. And so in terms of the demo, those are the two application templates we wanted to demo. Other than that, there is, if you go to the website, you can actually go to datatorrent.com/AppHub and you will find all the latest application templates there. So any of these templates, if you want to explore, you can simply download it directly from the website. So today we have not shown that flow, but you can download this and install it within your cluster. So essentially what will happen is the app template itself is packaged with the underlying DataTorrent RTS installation binary. So what happens is when you install the app template, RTS gets installed automatically, and then your application template is available on top of RTS. So next time onwards, since you already have RTS now, you can import it from the AppHub within RTS itself, right? So I think that completes the demo. I'll spend a few minutes on the roadmap, and that should complete the presentation. So as you have seen, so basically the point we wanted to get across today is it's very easy to import and launch the application template that you can do very quickly, right? And the other thing is it's very easy to add custom logic, and you can make use of all the platform capabilities that comes with Apache Apex and the DataTorrent RTS console. And in terms of the roadmap, the things that we are really focusing on are as follows. So one thing is visualizations. So today we have seen the management and monitoring console, which has some form of basic visualizations for all general applications and all. But we also have app-specific visualizations that we did not demo today. So we are building out those visualizations. So you'll have metrics such as, for example, for S3 to HDFS, you will have metrics such as amount of data moved, percentage of your ingestion completed, if there are any errors, number of errors, and so on, right? So that work is going on. So that's part of the roadmap and coming out very soon. And you can also define your custom user-defined metrics on top of your application template as well, and that you can expose it on top of the widget visualization dashboard. Other thing in the roadmap is cloud integrations. So we are heavily focused on AWS ecosystem integrations now. So there are two things there. One thing is installation script. So on the website, when you download, there will be an option to download the AWS installer as well. So what happens is once you configure your AWS credentials, if you run the script, you can configure the number of master node or number of task nodes and so on, and your security group credentials and all the configurations around security groups and so on. And then once you run the script, it will basically deploy EMR, install DataTorrent on it, and import the app template itself. So without having to do a bunch of manual work, the script will take care of automating this entire flow. right? Another thing we are working on is ecosystem templates itself. So if you're completely on Amazon and if you want to do some processing using Apex, like for example, Kinesis to Redshift or S3 to Redshift, so those templates are coming out soon as well. And other app templates we're working on, depending on the common use cases, are FTP to HDFS, Kafka to Elasticsearch, Kafka to Cassandra, and also with the schema support, we are adding the parsing, filter, and transformations as well to all of these app templates. So that's what is coming up in terms of the roadmap. And other than that, we have started focus on solutions as well. So we have started to figure out how can we apply these app templates to various vertical specific use cases. So that will come soon as well. So I think that completes the webinar presentation. So if you want to basically learn more about Apache Apex, you can go to apex.apache.org, or there are a couple of forums where a lot of discussion happens. The open source forum, you can find those details on apex.apache.org/community.html. There are the mailing lists for Apex users and Apex dev. Other than that, if you want to participate in the discussions for DataTorrent, RTS console, or app templates, then there is another forum, Google group called as DT users. You can go to DT users and ask questions. That's community support for app templates and DataTorrent RTS. And there are other URLs here as well. We will be posting the slide deck to SlideShare and uploading the webinar recording to YouTube, so you can refer to them back later as well. There are a couple of questions, so let me just answer them before we end the presentation. All right. So one question is data in XML format. Is there a separate template? Yeah. So right now the templates are focused on JSON and CSV, but we have operators in the Malhar operator library, the Apache Apex operator library, where you can parse XML, and there are two types of operators there, and one is based on XSD, and the other one is based on actually one is a DOM parser and other one is a SAX parser. So you can use any of those two formats. Those two operators for it. But eventually we will have app templates for XML as well. But in general, what we have seen is looking at the patterns people have use cases on, JSON and CSV come up more often than XML. So those were the first set of app templates we had. All right. Okay, and there is another question, which is anyone using these app templates in production environment? We have a lot of interest in terms of app templates and running app templates in production. We are working with a few prospects that are starting their end-to-end production deployments with app templates. So as you have seen, app templates is really focused on time to value, right? So for your or maybe if you even 50% there for the basic ones, but then you'll have to add your custom logic to go to production. So we have seen a bunch of users and customers start with app templates, but then they add their custom logic to go to production. All right, so I think that completes the questions as well. So thank you so much for your time and listening to App Templates webinar. I hope App Templates will be useful for you, and do feel free to give us feedback if you have any suggestions for us as well. Thank you so much.
Thank you for attending today's webinar. We will make this webinar recording available on our YouTube channel as well as post our slides on SlideShare. Be sure to subscribe to DataTorrent's YouTube channel and our SlideShare account, and follow us on Twitter at DataTorrent so you don't miss any upcoming content. Thank you for being a part of the Apex Meetup community, and we hope you enjoyed the presentation.